The next topic in this section is slant asymptotes. And so we have horizontal asymptotes, we have vertical asymptotes. These are diagonal asymptotes. So we actually find these by using long division. And they can occur when the numerator's degree is one more than the denominator's degree. Okay, so the directions for 13 want us to find these slant asymptotes. They also want us to find the vertical asymptotes and then graph it. So first let's find the slant, and to do that I want to solve by long division. So this is going to be, what do I need to multiply x by to get x squared? And that would be x. So x times x plus 2 is x squared plus 2x. Then I'm subtracting these. Negative 3x minus 2x is negative 5x. Bring down my negative 4. What do I need to multiply x by to get negative 5x? And that would be negative 5. And then negative 5 times x plus 2, I get negative 5x minus 10. And I want to subtract these, and I get 6. Now, I actually don't care about the remainder for slant asymptotes, so I can ignore the remainder. I only care about the quotient here. So this means the equation y is equal to x minus 5 will be our asymptote. Okay, for the vertical asymptote, I want to set the denominator equal to 0. So x plus 2 is equal to 0, and we get x is equal to negative 2. So for my graph, and just a rough sketch is okay. So x is equal to negative 2. That's going to be like right here. And then y is equal to x minus 5. That's going to be like right here. And then you can graph it on the calculator. So when graphing on the calculator, make sure to put a parentheses around the numerator and the denominator. So x squared minus 3x minus 4 divided by x plus 2. And the graph looks like this. And if you zoom out, so if you press zoom and 3 is zoom out, and then press enter, you can kind of see the other part of the graph is down here. So this really, if you want to see the asymptote on the grid, you can just type x minus 5 under y2, and then it should show you the diagonal line. So these two boundary lines really define this function.